index, that would be on used within a more traditional relational database. So it helps the database locate your data very, very quickly, to do queries of your data very, very quickly. And that's the whole idea behind the indexing. So in this case, we have lakes, and each feature or each lake is referenced by one or more tiles. The tile is the envelope of the feature determines the tiles that are occupied. So the envelope of the feature determines the tiles that are occupied. And the envelope is identified by the minimum and maximum x and y coordinate of each feature. So now you see we have this grid over the top of it, the ABCs along the x-axis, 1, 2, 3s along the y-axis. And the spatial index key records the occurrence of features within tiles. And of course, empty tiles are not stored. There's no reason to, and in fact, it would just be a waste of space in the geodatabase. The spatial index key is fairly easy to figure out. If we look at the grid X and grid Y, we see the very first entry for feature ID 15, is A4. And so if we go to that cell indicated by A4, indeed we see a little part of Lake 15, feature ID 15, exists inside that tile. Similarly, feature ID 15 or Lake 15 can also be found at B4 and C4 and so on and so forth. What I've highlighted on this slide, though, is feature ID FID 28 is indicated to be found at G3. And if we look at the cell or the tile called G3, it's clear that Lake 28, feature ID 28, does not exist in G3. However, while the feature itself doesn't exist, the envelope of the feature does. You see that red dashed line? That's the extent of the envelope. So that's another term that you will probably bump into as you're using ArcGIS and reading things about ArcGIS, is this concept of the features envelope. We can import a variety of data into a geodatabase. This includes shapefiles, coverages, XY tables. Typically this is done, XY tables is typically a Excel spreadsheet with spatial data stored tabularly, and then we're going to take that tabular expression of the spatial data, the x's and y's, and turn it into feature classes. This can only be used, by the way, for point feature class creation. We can also use generate files. We don't see this hardly ever anymore. However, it was very common when we had coverages and we were using ArcInfo workstation. We can also import standalone attribute tables. Again, this could be an Excel attribute table. This could be an old DBF attribute table that we bring in and can just bring it in as a standalone table. We can also create feature classes, and that's really one of the things that we're focusing on this week, creating our own feature classes from scratch. There's two ways that we can do it. One is the traditional arc node vertex approach, and the other, in specialized instances, the Bezier curve can work well for us. The Bezier curve will allow us to draw smooth lines, continuously smooth lines, such as you're seeing here, and this could be the end of a cul-de-sac, let's say, or any sort of other feature that literally is represents some sort of smooth line. We cannot do that with arc node vertices, however, because even if we are zoomed out, let's say, from that cul-de-sac, if we zoom in, we will see that what previously looked like a pretty smooth curve is in reality a series of short line segments connected to one another. And when we really zoom close, we'll say, oh, that's straight, and this part's straight, and this part's straight. All those individual line segments are straight. That's not how it works with the Bezier curves. However, what you should know is that if you use Bezier curves under the advanced editing options in ArcGIS to create some features or portions of some features, that if you convert that Bezier curve back out into, let's say, a shapefile, shapefiles do not support Bezier curves and that more advanced shape geometry. Shapefiles only support the ArcNode vertex style of creating features. So ArcGIS is going to have to do some interpretation, and the interpretation of that smooth Bezier curve is shown in the blue trapezoid. That's what you'll get when you convert a Bezier curve out to ArcNode vertex into, let's say, as a shapefile. So that's something certainly to consider when you are creating feature classes.